Welcome to this comprehensive guide to DevOps, a journey that will take you through the definition, key concepts, principles, tools, and best practices of DevOps. Whether you are a tech enthusiast or someone looking to embark on a career in DevOps, this guide is designed to provide you with a thorough understanding and practical knowledge of DevOps. Let's dive right in. What is DevOps? DevOps is a set of practices, tools, and cultural philosophies that automates and integrates the processes between software development and IT teams. It emphasizes collaboration, communication, and integration between software developers and IT operations to improve the speed and quality of software delivery. The term DevOps combines development and operations. Historically, development and operations teams worked in silos, leading to inefficiencies and bottlenecks. DevOps evolved from agile software development principles and practices, which prioritize collaboration, iterative development, and continuous feedback. The concept of DevOps emerged as a response to the challenges posed by traditional software development and IT operations. Traditionally, these two teams operated in silos, leading to a disconnect between development and deployment. This separation often resulted in delays, inefficiencies, and a lack of alignment in goals. Development teams focused on delivering new features and functionalities, while operations teams prioritized stability and reliability. This dichotomy created friction and bottlenecks in the software delivery process. The evolution of DevOps can be traced back to the need for better collaboration and communication between development and operations. It draws heavily from agile methodologies, which emphasize iterative development, continuous feedback, and close collaboration among team members. DevOps takes these principles a step further by integrating development and operations into a unified workflow. The term DevOps was popularized in 2009 by Patrick Dubois and Andrew Schaefer during the first DevOps Days event. This marked the beginning of a global movement that sought to bridge the gap between development and operations. Since then, DevOps has grown into a global movement, influencing how organizations develop, deploy, and maintain software. Key concepts of DevOps. To understand DevOps fully, it is essential to grasp its key concepts, which form the foundation of its practices. Continuous integration, CI. Continuous integration, often abbreviated as CI, is a DevOps practice where developers regularly merge their code changes into a shared repository. Each integration is automatically tested to detect integration issues early. The primary goals of CI are to improve code quality, reduce integration problems, and enable faster development cycles. In a CI workflow, developers frequently commit their code changes to a shared repository, such as Git. Every time code is committed, an automated build process is triggered. This process includes compiling the code, running unit tests, and performing other checks to ensure the integrity of the codebase. By integrating code changes frequently and running automated tests, teams can identify and resolve issues early, preventing them from escalating into more significant problems later in the development cycle. Example tools for CI: Jenkins, Travis CI, Circle CI, GitLab CI. These tools facilitate the automation of the CI process, enabling teams to set up pipelines that automatically build and test code changes. Continuous delivery, CD. Continuous delivery, or CD, extends the principles of continuous integration by ensuring that code changes are automatically prepared for a release to production. In CD, every code change passes through a standardized testing and deployment pipeline, allowing for reliable and rapid releases. The CD pipeline typically includes stages such as automated testing, integration testing, and staging. Automated tests validate the functionality and performance of the code, while integration testing ensures that the code works seamlessly with other components. Once the code passes all tests, it is deployed to a staging environment where it undergoes final checks before being released to production. Example tools for CD: Spinnaker, Argo CD, AWS Code Pipeline, Azure DevOps. These tools automate the deployment process, ensuring that code changes are consistently and reliably delivered to production environments. Continuous deployment. Continuous deployment goes a step further than continuous delivery by automatically deploying every change that passes the automated tests to production. This practice requires a high degree of automation and confidence in the testing processes to ensure stability and reliability. In a continuous deployment pipeline, every code change that successfully passes the automated tests is immediately deployed to production. This approach minimizes the time between code being developed and being available to users. Continuous deployment requires robust automated testing, monitoring, and rollback mechanisms to ensure that deployments are safe and reliable. Key aspects of continuous deployment: fully automated pipeline. From code commit to production deployment, the entire process is automated. Zero downtime deployments. Techniques such as blue-green deployments and canary releases are used to minimize downtime. Monitoring and alerts. Continuous monitoring and alerting systems ensure that any issues in production are quickly detected and addressed. Example tools for continuous deployment: Jenkins, GitLab CI/CD, Spinnaker, Azure DevOps Infrastructure as Code, ISC. Infrastructure as Code, or ISC, is a practice where infrastructure is provisioned and managed using code and automation tools rather than manual processes. IAC enables consistent and repeatable infrastructure deployments, reducing the risk of configuration drift and manual errors. With ISC, infrastructure is defined using code, allowing teams to version, review, and collaborate on infrastructure changes just like they do with application code. This approach ensures that infrastructure configurations are consistent across environments, from development to production. Example tools for ISC: Terraform, Ansible, Puppet, AWS CloudFormation. These tools allow teams to define and manage infrastructure using declarative configuration files, ensuring consistency and repeatability in infrastructure deployments. Monitoring and logging. Monitoring and logging are essential components of DevOps, providing visibility into the performance and health of applications and infrastructure. Effective monitoring and logging help detect issues early, understand system behavior, and improve overall reliability. Monitoring involves collecting and analyzing metrics from various system components, such as CPU usage, memory consumption, and network traffic. These metrics provide insights into the health and performance of the system. Logging, on the other hand, involves capturing and storing logs generated by applications and infrastructure components. Logs provide detailed information about events and errors, helping teams diagnose and troubleshoot issues. Example tools for monitoring and logging: Prometheus, Grafana, LK-Stack, Elasticsearch, Logstash, Kibana, Datadog. These tools enable teams to set up monitoring and logging systems that provide real-time insights into system performance and health. Microservices. Microservices is an architectural style that structures an application as a collection of loosely coupled services, each responsible for a specific functionality. Microservices promote scalability, flexibility, and rapid development by enabling independent deployment and scaling of services. In a microservices architecture, each service is developed, deployed, and scaled independently. This approach allows teams to develop and deploy features faster, as they can work on different services concurrently. Microservices also improve system resilience, as failures in one service do not impact the entire application. Example tools for microservices: Kubernetes, Docker, Istio, Consul. These tools facilitate the development, deployment, and management of microservices, enabling teams to build scalable and resilient applications. DevOps Principles. DevOps is built on a set of principles that guide its practices and culture. These principles ensure that DevOps implementations are effective and sustainable. Culture. The foundation of DevOps is a collaborative and inclusive culture that fosters communication, trust, and shared responsibility among development, operations, and other teams. A positive DevOps culture encourages experimentation, learning from failures, and continuous improvement. In a DevOps culture, teams work together towards common goals, breaking down silos and promoting cross-functional collaboration. This culture is characterized by open communication, trust, and a willingness to experiment and learn from failures. By fostering a culture of collaboration and continuous improvement, organizations can achieve faster and more reliable software delivery. Automation. Automation is a cornerstone of DevOps, enabling faster, more reliable, and consistent processes. By automating repetitive tasks, teams can focus on higher value activities, reduce human errors, and achieve greater efficiency. Automation in DevOps spans various areas, including CI/CD pipelines, infrastructure provisioning, and testing. Automated CI/CD pipelines ensure that code changes are built, tested, and deployed consistently and reliably. Infrastructure as Code, IAC, automates the provisioning and management of infrastructure, ensuring consistency and repeatability. Automated testing ensures that code changes are validated before being deployed to production. Lean DevOps incorporates lean principles to eliminate waste, improve efficiency, and deliver value to customers faster. Lean focuses on optimizing processes, reducing bottlenecks, and continuously improving workflows. Lean principles emphasize the importance of delivering value to customers quickly and efficiently. By analyzing workflows and identifying areas of waste, teams can streamline processes and improve efficiency. Continuous improvement is a core tenet of Lean, encouraging teams to regularly review and refine their processes to achieve better outcomes. Measurement. Measurement is crucial in DevOps to gain insights into system performance, identify areas for improvement, and make data-driven decisions. By collecting and analyzing metrics, teams can continuously optimize their processes and outcomes. Measurement in DevOps involves collecting data on various aspects of the software delivery process, including code quality, build times, deployment success rates, and system performance. This data provides valuable insights into the effectiveness of DevOps practices and helps teams identify areas for improvement. Sharing knowledge, tools, and best practices is vital for a successful DevOps implementation. The CALMS model, culture, automation, lean, measurement, sharing, emphasizes the importance of sharing in fostering a collaborative and innovative environment. In a DevOps environment, teams share knowledge, tools, and best practices to improve collaboration and innovation. This includes documenting and sharing lessons learned, using shared tools and platforms, and engaging with the broader DevOps community. By sharing knowledge and resources, teams can learn from each other and continuously improve their practices. DevOps Practices. DevOps practices are the specific actions and techniques that teams use to implement DevOps principles. These practices ensure that DevOps implementations are effective and sustainable. Version control. Version control is a practice of tracking and managing changes to code, configurations, and other files. It enables collaboration, provides a history of changes, and facilitates rollback to previous versions if needed. Version control systems, such as Git, allow teams to manage changes to their codebase in a structured and collaborative manner. By using version control, teams can track changes, collaborate on code, and ensure that changes are integrated smoothly. Version control also enables teams to roll back changes if issues arise, ensuring the stability and reliability of the codebase. Example tools for version control: Git, GitHub, GitLab, Bitbucket. CI/CD pipelines. CI/CD pipelines automate the process of building, testing, and deploying code changes, ensuring rapid and reliable software delivery. Pipelines consist of a series of stages, each performing specific tasks such as compilation, testing, and deployment. A typical CI/CD pipeline includes stages such as source code checkout, build, test, and deployment. Each stage is automated, ensuring that code changes are validated and deployed consistently and reliably. By automating the CI/CD process, teams can achieve faster and more reliable software delivery. Example tools for CI/CD pipelines: Jenkins, GitLab CI/CD, Azure Pipelines, AWS Code Pipeline. Configuration management. Configuration management in managing and maintaining the configuration of infrastructure and applications in a consistent and automated manner. It ensures that systems are configured correctly and remain in the desired state. Configuration management tools such as Ansible, Puppet, and Chef allow teams to define the desired state of their systems using configuration files. These tools automate the process of applying configurations, ensuring that systems remain in the desired state. Configuration management also provides versioning and auditing capabilities, allowing teams to track changes and ensure compliance. Example tools for configuration management: Ansible, Puppet, Chef, SaltStack. Infrastructure as Code, IAC. Infrastructure as Code, or IAC, is a practice where infrastructure is provisioned and managed using code and automation tools rather than manual processes. IAC enables consistent and repeatable infrastructure deployments, reducing the risk of configuration drift and manual errors. With ISE, infrastructure is defined using code, allowing teams to version, review, and collaborate on infrastructure changes just like they do with application code. This approach ensures that infrastructure configurations are consistent across environments, from development to production. Example tools for ISE: Terraform, Ansible, Puppet, AWS CloudFormation. These tools allow teams to define and manage infrastructure using declarative configuration files, ensuring consistency and repeatability in infrastructure deployments. Monitoring and logging. Monitoring and logging are essential components of DevOps, providing visibility into the performance and health of applications and infrastructure. Effective monitoring and logging help detect issues early, understand system behavior, and improve overall reliability. Monitoring involves collecting and analyzing metrics from various system components, such as CPU usage, memory consumption, and network traffic. These metrics provide insights into the health and performance of the system. Logging, on the other hand, involves capturing and storing logs generated by applications and infrastructure components. Logs provide detailed information about events and errors, helping teams diagnose and troubleshoot issues. Example tools for monitoring and logging: Prometheus, Grafana, ElkStack, Elasticsearch, Logstash, Kibana, Datadog. These tools enable teams to set up monitoring and logging systems that provide real-time insights into system performance and health. Microservices. Microservices is an architectural style that structures an application as a collection of loosely coupled services, each responsible for a specific functionality. Microservices promote scalability, flexibility, and rapid development by enabling independent deployment and scaling of services. In a microservices architecture, each service is developed, deployed, and scaled independently. This approach allows teams to develop and deploy features faster, as they can work on different services concurrently. Microservices also improve system resilience, as failures in one service do not impact the entire application. Example tools for microservices: Kubernetes, Docker, Istio, Consul. These tools facilitate the development, deployment, and management of microservices, enabling teams to build scalable and resilient applications. Conclusion: this comprehensive guide to DevOps has provided you with an in-depth understanding of its key concepts, principles, practices, and tools. By embracing DevOps, organizations can achieve faster and more reliable software delivery, improve collaboration, and continuously enhance their processes. Thank you for joining us on this DevOps journey. We hope this guide has been informative and engaging, and we wish you success in your DevOps endeavors.